Central South Pacific swell is hitting Hawaii. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 14th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write them up down below. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of your screen. That'll get you signed up. And if you'd like to make a contribution to support the cause, hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Matt Graves, E. Slate, Ramil Sarkov, Corbin James Corbin maybe? And then our longtime group of contributors, Evolution Moto and Tim Caston. Thank you all so much. And with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean, and we do see a gale producing 28-foot seas in the deep South Central Pacific Ocean. We see the ice line off Antarctica here ranging from about 64 to 65 south in the Southwest Pacific, and then maybe giving us a little bit more room in the Southeast Pacific down to about maybe 66. But for sure, ice building to the north, typical this time of year. It is winter down in the southern hemisphere, so one would expect a growing ice sheet. And that means less room for storm production and less room for winds to actually get purchase on ice-free waters. But that said, we still have a small gale offering us some hope for the future. But before we get into all that, let's take a look at current conditions. We're going to start looking at Northern California. We're looking at the buoys. Buoy number 157, Point Sur, California, roughly off Carmel. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period energy. That's really long period energy, and I assume everyone knows what period it is. It is the distance between consecutive swells from crest to crest in seconds. The longer the period, the more energetic the swell. And then the low end of the graph here is 5-second period. So 5 seconds between one crest of a swell and the next one coming in right behind it. That's pure wind chop. What we really want to see is something from 13 seconds and above. We don't see a whole lot of anything, but you do see this bit of energy in the 20-second range starting to show up. This is the beginning of two swells that are going to be overlapping one another, and the swell that is current, and this is the leading edge of the swell that is currently hitting Hawaii. And you see some other mixed background swell, I'll call it 13, 14-second period. And the good news is the wind swell is down to almost nothing. For the first time, it seems like this entire summer, whenever we've had a southern hemi swell, there's been a whole bunch of wind swell with it, and it just trashes it north of Point Conception. Finally, it looks like we're getting a break. All right, so we're going to go pull this all together. Let's see what it, primary swell, 2.6 feet at 9 seconds from 306 degrees. That's down in there. And that would make surf at about 2.5 feet. What's that, thigh high? That's probably about what it is. And then some secondary swell, 1.3 feet at 12.7 seconds from 191 degrees. Background southern hemi swell, 1.7 feet, not even rideable. I mean, all the South Basin breaks are effectively flat. And the 20-second period swell that we saw in the graph down here is so small, it isn't even showing up. It's getting beat out by 2-second period wind swell. So, we're on the hairy leading edge in Northern California. Let's go look down south. We'll go down way down south off of San Diego, the Point Loma South Buoy, number 191. Again, the same profile. Little bits of 20-second period energy, little bits of 13 and 14-second period energy, and little bits of wind swell. The wind swell, even smaller, protected by the Channel Islands. So we go take a look at how this all breaks down. Primary swell, 1.1 feet at 13.3 seconds from 195 degrees. 1.5 feet, pretty much not even rideable. The wind swell, 1.4 feet at 9.3 seconds. 1.3 feet. not really a whole lot of anything. All right, let's move on to the Hawaiian Islands. The Lanai buoy, south of Lanai, buoy 239, protected from all the wind swell. Now we have a much better situation. You can see 18-second period energy with a whole bunch of stuff down here to 13 seconds and up to 25 seconds or even a little bit more, 28 seconds, something like that. So this is actually two swells, a primer swell and the main swell. The main swell is just starting to hit here as we speak. We can pull this out here. Primary swell 2.2 feet at 17.3 seconds from 183 degrees. That puts surf theoretically, if you just run the math, 3.7 feet. There are waves that are a foot overhead, maybe a little bit more on top spots in the south shore of Oahu. 3.7 feet Hawaiian. Yeah, maybe that's about a foot overhead, something like that. And then the secondary swell, this is from the first push, the primer swell, still hanging in there, 1.7 feet at 14.1 seconds from 188 degrees. 2.5 feet, that's Hawaiian. Just for a normal beach break, it'd be 2.4 feet, but you have the reefs, and channels, and positive or conducive bottom bathymetry that enhances the height of any incoming swell. Not quite double, but Hawaiian, yeah, you could call it double, but that's probably about shoulder to chest high, something like that. So a much better picture in Hawaii, and that is moving towards California. So let's get into the specifics. Where is that swell coming from? All right, so we're going to go back in time to Friday night or early Saturday Zulu time, July 6th, so about a week and a day ago. New Zealand here, Australia here, there's your Antarctic ice, it's in gray in this image. A gale started developing south of Tasmania with 29.9 foot seas. That right there, that's the highest seas over the entire image or the entire domain. You even have its coordinates here, 60.25 south, 141.25 west. That's really not really certainly not in the Hawaiian swell window and not really in the California swell window either, unless there was like 40-foot seas down here. But you get the idea. There are seas. The gale is traveling this way. Well, we'll just put it in motion. You can see for yourself. This is the primer gale. I'm calling it 26 to 27-foot seas as we got into through the day Saturday, lifting up off New Zealand. Now, there was another gale here with 30-something foot seas, but that was all aimed south and basically nothing. If the fetch isn't pushing towards you and the seas aren't pushing towards you, you aren't going to get a swell from it. So this is what we're calling the primer gale, and it had continued into even Sunday. And then as we got into late Sunday night, early Monday, the 8th of July, this system started developing with 32, maybe 33-foot seas. Again, this 36.8 feet, that's over here going south, of no concern to us. And then we continued with 30, 32, 34, maybe 35-foot seas as we got into Monday morning, all aimed well to the north. Now, this is the main event, right? This is the storm that produced the leading edge of the swell that's hitting Hawaii. Whatever's hitting California is from that primer gale that pushed under New Zealand. This system continued and actually built a little bit more as we got into Tuesday with 39.7 foot seas at 52 south, 154 west, so right there. And that's why I called this a Central South Pacific swell, because that's really a pure New Zealand swell would be over here. This is it's on the hairy edge, actually, of the Hawaiian swell window right there. That's the most. Oahu's at 158 west, so that was on the hairy edge. But the best part of this storm really is bypassing Hawaii. It's going to be interesting to see what the buoy gets to, later tonight into early tomorrow morning for Hawaii. But I'm kind of thinking maybe a little bit more energy pushing towards California. The issue is right up here. Where is it? Yes, right in this area. The Tahitian swell shadow will be in full effect. And of course, if you all were on Instagram or anything, you saw when this swell hit Tahiti. Very solid swell indeed. In fact, there were some buoys, floater buoys down in here. Two of them, I saw a max reading of 113 and 114 feet at 16 seconds before that swell hit Tahiti. So pretty solid swell indeed. We'll see how much of it makes it through the cheese grater to California. Anyway, as we got into Tuesday, you can see the storm started to fall apart, and that was it. Yes, there is some additional energy over here, but the eastern edge of the Southern California swell window is right about here. All this energy was aimed due east, if not southeast, and so don't think we're going to see anything from that. That said, there's still a good amount of swell pushing to the north. All right, so that gets us into Friday. Now, swell from this for sure for Peru and Chile, indeed. But for California, no. And let's see, just get ourselves here into, well, there's Saturday. Now we see this little bit of a gale here, another system that started developing just Saturday night into Sunday. That is today, the 14th. And that is, let's see, right there. That's our current situation. So now that begs us to go look at the forecast. So what's coming for the next week? We're going to start not down at the ocean, but we're going to go up in the atmosphere. We're going up to look at jet stream level winds. These winds up about 30,000 feet. They help support the formation of gales that create surf, and the jet stream helps direct their track. If you can look at the jet stream and get a sense of what's going on, it will tell you pretty accurately whether there's really any hope for surf or not, because you need to have a trough. We're looking for a trough. A push in the jet to the north. We kind of almost see it right here. Here's the northern branch. That really doesn't do a whole lot for storm production. It's the influential southern branch of the jet right here. And when you get this push to the north here, what you'll get is a clockwise flow or a clockwise eddy aloft. And that'll also manifest itself down at the surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds at the ocean surface. Those winds get traction on the ocean surface, generate seas. Those seas, as they start radiating away from the fetch area, get groomed out and eventually turn into swell. Of course, swell, when it hits your beach, turns into surf. So we have, right as of 18Z Sunday, something that kind of almost looks like a trough. We know there is some sort of low pressure down in this area that has generated 28, 30-foot seas. So I guess we can call it a trough. But here, as we get into Monday, you see the trough becomes a little bit better defined, being fed by 140-knot winds. And then it sort of weakens, starts pushing out of the California swell window. But back under New Zealand, here we go. Another push of wind energy starts setting up. Now, not as strong, and we're into Tuesday, the 16th of July here with 120-knot winds. Not particularly strong. But then as we get into Wednesday night and Thursday, here comes another push of winds at 130 knots. Yep, and building yet a better trough. So it actually looks like we're trying to get some sort of a pattern that's focusing more on the southeast Pacific, whereas so far all this year, everything's been really under New Zealand. This pattern continues, and there you got the trough. That is a true push to the north there on Friday night, the 19th, into Saturday, the 20th. So maybe there's some hope there, and we'll just sort of go out a little bit further, and then it starts fading out. So the other thing we're kind of keeping our eyeball on here is the Olympics, Tahiti. On, when is that? The window opens on the 27th and goes through August 4th. So we're still a bit early, and what is it? It's only about 3 or 4 days travel time from down here up to Tahiti. But as of right now, all this focus, Tahiti again is at like 140, I believe it is, 140 and roughly somewhere up in here, 18. So all this energy, for the most part, is east of the Tahiti swell window. But we will keep our eyes on it as we get closer to Olympic time. All right, so that's the jet stream, but it actually takes winds blowing on the ocean surface. And those winds, they rough up the ocean surface, but what they're really doing is they're imparting energy to the ocean, and that energy gets translated and or gets transferred from wind energy to swell energy. All right, so as of Sunday, we do have winds 35 to barely 40 knots, generating those seas clear of the ice line. The ice line's, again, right down around here. So there is some fetch generating swell, and that's supposed to continue into Sunday night. You see 40-knot winds aimed a little bit better to the northeast. Southern California gets cut off about 117 west here. I think that's where San Diego is. So fetch continuing even into, well, nonstop, it looks like. 35 knots is really not enough. You really need 40-knot winds, but anything, there's 45 knots over a tiny little area. So we're into Tuesday night, Wednesday. Oops, look at that. There's actually a pretty good little, it's not big, but at least some hope. So, and right on the hairy edge of the Southern California swell window. So actually some hope, and then continuing on into focusing more on Chile and Peru beyond there. Then we get into Thursday. We know the Jetstream's still doing well, and here's some 35-knot winds, but I'm not sure if that's enough. We probably need 40-knot winds minimum. We're trying as we get into Friday and Saturday, but we're almost a week out now. Not really believable. Now we see two other systems forecast, one off New Zealand and one here just south of Tahiti. But these guys, again, they're falling south. Even though this one has fetch aimed to the north, the southward falling motion never bodes well. You really want the fetch pushing towards you. So that's what they call a captured fetch. That is, when the wind blows, it creates seas, and as the seas try to escape, the system pushes northeast, and then it piles yet more energy on top of that already roughed up ocean, and on top of the seas that are already building. But what these systems are doing is falling south as the seas are escaping to the north, and it just doesn't give them any momentum, and just doesn't bode well for swell production. That said, we'll keep our eyes on it. All right, let's go take a look at the wave model. This model is really a product of the wind model. It's actually the GFS wave model now. The wave model and the wind model are all one and the same. It's just another product, another dimension of what the model produces. This model, the wave model, uses GFS winds to predict how much energy is being imparted to the ocean surface, and then translates that into wave heights, which then we can use to extrapolate to see swells and potential for surf. All right, so anyway, we get in Sunday night. Here's this gale. We were looking 28-foot seas, 29.7, excuse me. A little bit better, and building some to nearly 30 feet. Yep, there. One little square of pink there. 30 feet. Okay, so some little swell probably will result from that. And then as we get into Tuesday, that system starts fading out. We know more energy is to be building over here, but the focus, it's out of the California swell window. Focus really is Chile and Peru again. We'll just keep rolling this out. We know there's more fetch, but you see, because the winds are not exceeding 35 knots, and it's 35 knots is what gets you 20-foot seas. You really need something more than that. 35-knot winds get you 13-second period swell if it's blowing over a long enough area and a bunch of other qualifiers, and that's really not enough to even survive the journey up into California, much less fly. So here's our two other systems. Yes, 30-foot seas. Maybe we could eke something out. This is, again, a week out. Never believe a model a week out. Most of the energy, you can see there's a little arrow right there. 40-foot seas, all aimed southeast. It's off the backside of this thing. If anything is happening, then it'd be a very south angle at that. So, and again, don't believe the model's a week out. But we'll see. There is a little bit of hope. And then wind forecast. Well, we've been plagued by strong high pressure. Our El Nino from last winter was plagued by strong high pressure, and it kind of just, took the sails, took the wind out of it, or took the, didn't do I don't remember what the metaphor is, but anyway, you get the idea. And all spring long, it's been nuking northwest winds north of Point Conception right there. Finally, we have a weaker wind pattern. Light winds along California today, and trades 15 knots, pretty much standard fare for the Hawaiian Islands. As we get into Monday, more of the same. This weak little low pressure system, either northwest winds or light south winds, pretty much neutral. Whatever fetch there is on the Oregon-California border and not doing anything to produce meaningful wind swell. Trades for the Hawaiian Islands. Tuesday, same deal. Wednesday, maybe a little bit more of a northwest wind regime, but we're talking 10 knots. Trades lighten up for the Hawaiian Islands. Notice some sort of a tropical low hinted at down here. We'll see. This model tends to overhype the tropics a lot. So we get into Thursday. Now the northwest winds start trying to build a little bit more off the coast, so probably not too much interference with the swell that should be coming into California at that time. And trades 10 knots for the Hawaiian Islands, so pretty light. But as we get into Friday, here we go. High pressure ramps up again as low pressure clears out. Northwest winds 15 to 20 knots, same deal. Tropical system, light trades for the Hawaiian Islands. Saturday, back to the full-on northwest wind swell, 20-25 knots. Things just blown out north of Point Conception. Trades light for the Hawaiian Islands. We'll roll this out, see what this tropical system does. Oh, and as we get into Sunday, full-on blowout for North and Central California. Trades for the Hawaiian Islands. Tropical system fades out. And again, that's probably overhyped. And then here comes our high pressure filling the Gulf of Alaska. Nuking northwest winds. If you're into wind swell, there'll be plenty of it relative to breaks in Northern California and Central California. Light winds for the Hawaiian Islands. All right, surf forecast. We'll start for Northern California, Santa Cruz. Roughly speaking, this isn't like down to literally Steamer Lane or Pleasure Point or something like that. It's just a generic kind of forecast for the area. Use your local knowledge to figure out where to be and when to be there. But the general trend is you see some sort of a building swell pattern Monday into Tuesday, into Wednesday, even into Thursday. Then we know there's wind swell coming in here. The winds, you can see them building when the winds pick up. Whatever is real swell starts fading down. Let's go take a look at actual swell sizes here. So here we go, 17 seconds on Monday, 1.3 feet at 17 seconds. So not particular. This is the primer swell coming in, building to 2 feet at 16 to 17 seconds on Tuesday, building to 2.5 feet at 16 seconds on Wednesday into Thursday. Nothing huge. And then you see the wind swell starting to build and the occasional bits of 2 feet at 14.5 seconds, 1.5 feet at 13.5 seconds as we get into Saturday. So basically, surf all week, smaller in the beginning, a little bit larger later in the week, and then a little bit windy later in the week. Then we go to Southern California, Dana Point, good representation of all of California. Now you see the same sort of a pattern of a building swell Monday into Tuesday, holding Wednesday into Thursday, starting to fade out and slowly drop down. Local winds really light. Let's go look at the swell profile. A little bit less wind swell here. Here we go. 1 foot at 18 seconds as we're into Monday early morning. So not a whole lot of size initially. Building to 2 feet at 17 seconds. 2.3 feet at 16 to 17 seconds. You get the general idea. And slowly fading down from there. That is the primer swell and the main swell, and then the decay of both those swells into the weekend. And then just to be consistent with the buoy that we looked at, Lanai, Maui's close enough. You see peak of the swell, 4.4 feet. One can assume this is Hawaiian. This would be Monday morning, and then slowly dropping down from there. Trades pretty light the whole time. Let's go look at actual swell. 2.6 feet at 16 seconds Monday morning. Continuing into Tuesday, but the period dropping out. Wednesday, 1.5 feet at 13 seconds or so. Dropping Thursday, and you get the general idea, and then just drifting away into nothingness beyond that. And then one other forecast. No, this is not surf. This is for people that backpack or who are on the Pacific Crest Trail. This is the intersection of the Pacific Crest Trail high in the Sierra where it intersects with Tioga Pass Road in Yosemite National Park. Where the road and the trail intersect is right at about 8,700 feet, so that's what this line is. But depending on how high you're hiking, if you're up at 10 or 11,000 feet, you can pick out the temperatures here. But right at the intersection, temperatures generally for the next, this is a 10-day forecast, 55 degrees, peaking up into 60 during the day, 55 at night, and then maybe warming up a little bit as we get into here. We'll see if we can get this centered for you. By next weekend, Friday, Saturday, temperatures generally 65 to 70 degrees, something like that, and holding the whole way into the end of the model run, which is Wednesday, July 24th. So not too bad here, maybe a little bit warm as you get towards next weekend, but not unmanageable. All right, so let's go look further out. We're going to go look at the two major weather oscillations that affect surf production long term. They are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. That is El Nino or La Nina. We'll start by looking at the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. The active phase is our friend, the inactive phase is not our friend, because the active phase, when it moves over the far west Pacific, takes warm, moist air. It's like a low-pressure system. It takes warm, moist air that's down at the ocean surface, lifts it or sucks it up high aloft up into the atmosphere. That wind energy, or that actual warm, moist air, gets tapped by the jet stream, makes the jet stream more energetic, and the stronger the jet stream is, the better the chances for troughs, and that means better the chances for storm production. Conversely, the inactive phase of the MJO is like a high-pressure system. Oh, and the MJO, there's the two phases of it. They rotate around the planet from west to east on opposite sides of the planet. So when the active phase starts moving over the West Pacific, that typically feeds the jet stream, which feeds storm production. The inactive phase is like a high-pressure system. It cuts off the flow of moisture up into the upper levels of the atmosphere, starves the jet stream of energy, the jet stream splits, and then you don't get storm production. All right. So we're looking for signs of the active phase of the MJO. The other thing that the active phase of the MJO does, because it's a low-pressure system, it dampens trade winds. Trade winds are generated by high pressure. If you have the active phase moving across the Pacific, and it moves west to east on the equator, the whole way around the planet, so does the inactive phase. That low pressure of the active phase dampens trade winds. So we're going to start by examining trade winds. This is data from the TAO buoy rays series of buoys strung across the equator in the Pacific, used for monitoring El Nino, but there are wind sensors on those buoys. This is the East Pacific here, this is the West Pacific here, that is New Guinea there. The international date line is right there. Otherwise, there is no land on this chart because it's only 10 degrees north, 10 degrees south of the equator. Really, it's only 5 degrees north and south of the equator that really matter. The arrows are the wind speeds, average wind speeds. The longer the arrows, the stronger the wind. So trade's pretty strong here in the East Pacific. In the Central, Hawaii's like at 158, so right here. So in the Central Pacific, trade's moderate. And in the West Pacific, trade's weak to moderate. But it is not the actual wind speed. It is the anomalies, the difference from normal for this time of year. So we look at these arrows and go, oh, the difference between actual versus what is normal, they're a little bit stronger than normal, so that's not so good. Over the Central Pacific, not so bad. You get into the West Pacific, just a hair bit stronger than normal. So this suggests neither the active or the inactive phase, but if anything, I'd say the balance is towards the inactive phase. Let's dig a little deeper. What have the winds been doing for the last 5 days? All right, this is 850 millibar vector wind anomalies. So it's not at the ocean surface. This is up about 4,700 feet. But a good proxy for what's going on at the ocean surface. The blues are easterly anomalies. The oranges, westerly anomalies. So there's South America, Central America, Australia, New Guinea. 0 is the equator. Dateline roughly here. Where the MJO, the active phase of the MJO, does its magic is right here in the West Pacific, near New Guinea, out to a little bit beyond the dateline. So right in here, 5 degrees north and south of the equator. So on July 8th, weak westerly anomalies, they held on the 9th, the 10th, the 11th, and even into the 12th. Well, that was what, 2 days ago? So looking at this, not so bad. I wouldn't call it anything like a strong active phase, but certainly not a inactive phase, much less a strong inactive phase. All right, so here is the 2-week forecast. 850 millibar zonal wind anomalies. The same deal, up about 4,700 feet. But this is the whole planet on one chart, so we got to just look at a fragment of this. This is what has been happening, and this is what the forecast is. And you can see right out here, big blues and purples. Those are easterly anomalies. That would be, one would attribute that to the inactive phase of the MJO. And you can see, well, here's the date line running right up the middle. Far West Pacific starts about 125 east, so right about here. So our area of interest is from here to about 170 west. That's where all the magic happens with the MJO and the Jetstream. So here is these week 1, 2, 3, 4, 5 days. Here is these weak westerly anomalies that we saw in the previous chart. But starting about today and going forward, this chart suggests, yeah, westerly anomalies holding in the very far West Pacific, but easterly anomalies just taking a strong grip on all of the Pacific. Another little pulse of westerly anomalies trying to make headway, but notice neither of these make it further than about 150 east. That's barely halfway through the Kelvin wave generation area. That is probably a sign of what is to come for the next 6 months to a year, something like that. But let's keep digging. So here is another way to look at the MJO. This is outgoing long wave radiation, fancy words for cloud cover. If the active phase of the MJO is like a low pressure system, and it is taking warm moist air and sucking it up into the atmosphere, eventually that warm moist air is going to hit cold air aloft, condense, and form clouds. That's effectively what this model is showing you. On average, is it cloudier or less cloudy than normal? Okay? The blues are cloudier than normal. The oranges and reds, less cloudy. Officially, it's outgoing long-wave radiation, sunlight reflecting off the ocean surface. More sunlight reflecting the oranges means no clouds. The sun can, work its way through the atmosphere, hit the ocean, bounce right out, and bounce back into space. Where if you have clouds, they're going to absorb some of that sunlight and hold it in. All right? So, South America, Central America, Australia, New Guinea, the equator running right there, dateline right there, the area of interest right here, 5 degrees north and south of the equator. Blues, less sunlight reflecting off the ocean surface, the active phase of the MJO today, according to this, a statistic model. And that pattern holding, if not building, 5 days from now, and continuing 10 days from now, then faltering 15 days from now, or 2 weeks. That looks positive. Let's go look at another model. This is the GEFS model. The GFS model, the same model we were talking about, this is the ensemble version of it. They run it multiple times and compare and contrast the differences. This model says not only do we have active phase of the MJO 10 days out, but it also continues 15 days from now. So, a reasonable forecast suggesting that we are in a sweet little spot right now to support storm production. Let's go look at the phase diagrams. These are the same two models, statistic model here, dynamic model here, but these are the detailed charts that show you exactly where the center of the active phase is and how strong it is. But how do you read this mess? Well, the MJO moves from west to east, from the Indian Ocean to the Maritime Continent, West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is right here is where the active phase is today. So over the Maritime Continent. Bali, maybe a little bit, maybe north of Australia more. Okay? The further the dot is away from the circle, the stronger it is. So a very weak active phase, 1, 2, 3 different forecast tracks, all of it being over the West Pacific 2 weeks from now. Each dot is a day. There should be 14 or 15 dots in each of these. All of them lined up in the West Pacific, but all of them very weak. The dynamic model basically shows some version of the same thing, with the active phase sort of meandering around here, about where it is for the next week, and then eventually making its way towards the West Pacific, but also very weak. So the model's pretty much in sync. Upper level model. This again shows basically outgoing long wave radiation or propensity for precipitation. The orange is dry air, the green's wet air, the green active phase, the MJO, the orange inactive phase. Now this goes out 40 days, 5 days a panel. South America, Central America, New Guinea there. 0 is the equator. Date line roughly right down here. This is a great chart for just showing you high-level MJO. You can see the active phase here over the maritime continent. Well, let's see, Bali's like right in there. And roughly, this is where the active phase is. You see it making its way into the Pacific on July, what is that, 19th? And continuing, fading out about August 3rd. But this is the upper level. Add another week to that, so maybe into July 10th or something. I mean, August 10th, something like that. And then the month of August, here comes the inactive phase of the MJO, dry air. And that does nothing to, one can assume that means high pressure, and that means cutting off the flow to the jet stream. That means a split jet stream and low odds for storm production. Doesn't mean it isn't going to happen, but just the deck isn't stacked as in favor as it is for the next 2 weeks. So this is our sweet spot. Then we go look at the CFS model. Again, 850 millibar zonal wind anomalies. So this is not potential for precipitation or wetness in the air. This is winds at the ocean surface. We have good potential in the upper atmosphere, but what's going on in the lower atmosphere? All right, the oranges and reds are westerly anomalies. One would typically say the active phase of the MJO. The blues are easterly anomalies, the inactive phase. In fact, the MJO is annotated here by a black line. The dotted black contour is the inactive phase. And here you see inactive phase and easterly anomalies. Active phase and red westerly anomalies. Now this was back in April and May. Oh, and the date line runs right through the middle. So this is the whole planet. All we care about is from 125 east, so from about here to just east of the date line. And this is past performance. Here's our forecast right here. So today, inactive phase, somewhere pushing south of California with easterly anomalies. But these other easterly anomalies are just kind of hanging out on the date line, even west of the date line. Active phase, westerly anomalies, this would be over Bali and the maritime continent. They try to work their way into the Pacific, but only make it to about 150 east. So that isn't very far. That's 40-50% of the Kelvin wave generation area. Here is our active phase forecast for the end of July, and it happens, but easterly anomalies in control, and you can kind of see it over here. So the real transit area is something like this here. And this speaks to probably the building La Nina pattern, but we won't go into that just yet. And then finally, the CFS model going out 3 months. Past performance down here, the forecast up here. Same deal, 850 millibar zonal wind anomalies. The blues, easterly anomalies. One can roughly equate that with the inactive phase of the MJO. And the yellows, westerly anomalies, the active phase of the MJO. But looking at the forecast, we have just a wall of easterly anomalies. Where's the date line? Right there. So our main area of concern, 125 east. So there. That's the beginning of the West Pacific. The dividing line between easterly anomalies and westerly anomalies, pull down right there, about 150 east, something like that. And so here is the westerly anomalies, light as they may be. And then you see easterly anomalies building in over the next week, and they pretty much lock down everything from 150 east and for the foreseeable future. This really smells to the development of La Nina. El Nino, the El Nino signal now building over the maritime continent. And the Indian Ocean, that is classic La Nina kind of setup. Let's overlay the MJO here. Oh, and look at this. The MJO just deader than a doornail. The dotted contour, inactive phase of the MJO, pretty much gone. Here's our current active phase of the MJO that's forecast for the next week or two. After it does its thing and it's super weak, it just dies. Westerly anomalies just continue to retreat. Another active phase does nothing to poke a hole in this building area of easterly anomalies. And after that, it is just easterly anomalies in control. Let's overlay the low-pass filter. Now, this really tells the picture. This solid contour here, well, actually, let's go last winter down here, or even spring. Solid contour, low-pressure bias. One can roughly equate this with El Nino. And El Nino, or the low-pressure bias, was in the Pacific right over the date line. And then as we got into May, notice it faded and started building over the Indian Ocean. And now we have two contours over the Indian Ocean. And what do we have here? High pressure, the dotted contour. High pressure setting up, and about a week from now, it basically filling almost the entirety of the Pacific, except for that one little area from 150 east to the, to New Guinea and a little bit west of there, yeah. So definitely this model, and this model's been rock solid. All the models really have, suggesting some sort of La Nina building. The real question is, how strong will it get? So that brings us to the El Nino La Nina part of the discussion. Remember the long-term forecast broken into two parts, the MJO, which is sort of a shorter-term thing, and then the ENSO component, the El Nino La Nina, the longer-term component. We'll start by looking at subsurface water temperatures, because what El Nino does is takes warm water that's normally sequestered up in the far west Pacific, starts pushing it east. That drags the jet stream with it, that drags storms into California, that produces low pressure in the Gulf of Alaska in winter months, and produces storms and surf and snow. But when the exact opposite happens, when high pressure starts setting up in the Pacific, you get those easterly anomalies like we were seeing. Increased trades, they take the warm water that can build up in the West Pacific from El Nino and shunt it all off to the west. All right, so here is data from the TAO buoy array. Again, those buoys strung across the equator. These X's are the sensor. These are the anchor lines on those buoys. The X's are sensors on the anchor lines. They collect temperature data. You use a model to fill in the gaps, and you get a profile of what's going on in the Pacific. This suggests that the warm 30-degree isotherm, this is centigrade temperatures, warm water, is from the date line and west of there. The 29-degree isotherm takes it to about 170 west, which is about where it was last week. 28-degree isotherm at 152. I actually think it was about 150. No, it might have been 150 somewhere in between 150 and 155. So it's holding about the same. The 24-degree isotherm backtracking. Now notice, in this area, there's no little X's in here. A big chunk of the array is down. So there's a big question mark on what's going on here, but I'd say this 24-degree isotherm thing going this far to the east to, California's at 120, so this is somewhere down in, the equivalent of south of deep in Mexico. That's probably very optimistic. And then we go look at the anomalies, the difference from normal for this time of year. It shows this big cool pool down here. What is that, south of 150? So that'd be south of Hawaii. This is down in the oceans. And it shows 1 degree positive anomalies off of Ecuador. And that's just not happening. I think yes, there probably are, there are sensors right here, and they're suggesting 1 degree anomalies, but there's this whole area in here. So there's nothing going on. I suspect, if anything, the cold water is working its way up in here. And the good news is, we have yet another chart here. This uses the same TAO buoy array data, but it also uses a satellite to map the height of the ocean, and one can infer, if not like wave heights or sea heights, but is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts It'll make and the water above it gets displaced down. You'll get a dip on the ocean surface. Warm water at depth expands. It'll displace the water above it up. So this is suggesting that there is a depression in the ocean's surface here. This is the East Pacific. This is the West Pacific. So there's all our warm water starting to rebuild, recharge mode from El Nino. Warm water starting to recharge in the West Pacific. Lingering warm water from El Nino still in play. I mean, not too bad, even to a point south of California. This is just on the equator, 5 degrees north and south. But then this clearly shows cold water Kelvin waves erupting to the surface, and some of that cold water, though it doesn't show it here, likely getting dragged off to the west on the ocean surface. So this is probably a closer depiction of what's really going on. Here's the sea level anomalies. That's what we were talking about earlier. This is Chile, Peru, Ecuador, Central America. I know it's kind of weird looking. The equator right here. The date line right here. Hawaii is right there. The Galapagos are right there. New Guinea, Australia. So these are not temperatures. These are the height of the ocean in centimeters and the difference from normal. Minus 10 centimeters, minus 15, minus 10 centimeters, minus 5. So this whole area from Ecuador, 5 degrees, that's 10 degrees north, 10 degrees south, 5 degrees north, 5 degrees south, all negative. This isn't really any different than it was last week. I mean, this is not some sort of a mega La Nina or anything, but this is a definite tendency towards La Nina. It won't take much, though, to get this thing probably building a little bit. Also notice positive anomalies, this little horseshoe thing going on here, suggesting that you have trades pushing into this and sort of like cutting a hole through the positive anomalies as warm water tries to build or actually tries to run off the maritime continent here, and it just hits this river of westward moving trade wind driven water and just blunting its path so it can make no progress to the east. Classic, La Nina kind of setup. Upper ocean heat anomalies, again, West Pacific here. Whoops, there we go. East Pacific over here. The warmer than normal temperatures. The blue, colder normal temperatures. This goes back a whole year. So August, September, October, November. This is all the peak of our El Nino. Active phase driven Kelvin waves. That's warm water being pushed across the Pacific. All here. And then we got to January and the whole thing shuts down. There is no more warm water left in the West Pacific. And so it starts making its way across cold water. I think what they call them, upwelling Kelvin waves. So there's one there. Here's another there. Here's a third here. This was in May, in June. We've been in a bit of a break. You see a bit of warm water trying to rebuild. Not like this is a Kelvin wave, but more is the trades just died. The sun got to warm up the surface. But then you get the definite sense that here comes yet another building cool phase. Now, not like this, not like a real Kelvin wave, but just, easterly trades, roughing up the ocean surface, creating upwelling. You get the idea. So let's go look at the ocean surface. Sea surface temperature anomalies. It is the water on the ocean surface that really makes the difference, because that warmer than normal water creates evaporation that starts lifted up in the atmosphere, creates storms and hurricanes and all kinds of stuff. Now, clearly, here's the United States, South America, Australia, China, Soviet Union, Africa over here. Just looking at this, everything's warmer than normal. When scientists say they're concerned about the warming oceans and about the planet warming, and this is even what constitutes warmer than normal. This chart even has I think it's a 5-year roll. It's actually a 30-year average, but every 5 years they update it based on what is considered normal, because everything's warming. And even with that, everything is much warmer than normal. All this warming here in the Atlantic here, the main development region right down here, the Cape Verde Islands. This is the Cape Verde Storm Corridor. This is why scientists and climatologists are a bit concerned because if you're in La Nina, that dampens the shear over the Atlantic, and then you have all this warmer than normal water creating more evaporation that just feeds hurricane development. Beryl went right through here, and normally there would be a cold little track where it went because it had 150 mile-an-hour winds. That should create some upwelling. Didn't even put a dent in it. Now, Beryl wasn't a huge storm, and it was moving pretty fast, but just the same, not even a dent. So hopefully that is not a harbinger of what's to come for the hurricane track. And then here in the North Atlantic, in fact, someone asked, could you talk a little bit about the Atlantic? So I'm talking about it now. Much warmer than normal water temperatures up here. In fact, historically warm temperatures in the North Atlantic. I don't know if that really does anything so much for hurricane development. It's mainly down here, but, the same pattern. Things are much warmer than normal. In the Pacific now, so here is, we know we had colder than normal water down below, and we're getting some cold water Kelvin waves. You see little evidence of it right here, and all that matters is 5 degrees north and south of the equator. So a weak sign of La Nina, but nothing too particularly impressive, and there's all this warm water hangover from El Nino and the global warming, or whatever you want to call it, pattern hanging out here. But the balance of the warm water now over in the far west Pacific. Sea surface temperatures in the Nino 1.2 region. This is the sea surface temperature anomalies. In fact, temperatures were falling as 0 is neutral. Up here would be El Nino territory. This is not the main El Nino monitoring region, but you get the general idea. This is over by the Galapagos and Ecuador. Temperatures had fallen to 1 degree below normal, and then La Nina kind of faded or stalled. And you see temperatures creeping back up to neutral. Now today, 1/4 of a degree below normal, 275 thousandths of a degree below normal. So, if you're toggling between 1/2 degree below normal and 1/2 degree above normal, that's considered normal. There is variability. Everything isn't rock solid. Okay, let's go, though, to the official El Nino monitoring region, the Nino 3.4 region. So this is the area 5 degrees north of south of the equator from 120 west, so due south of California out to almost the date line, 170 west. Temperatures, yeah, we were up at 0.8 of a degree above normal, but since May, we've been just pinging around right around dead neutral. Where's 1/2 degree? Oh, 1/2 degree is here, and 1/2 degree is here, so the scale's different on these two charts. So we're just pinging around in neutral territory today. 18 thousandths of a degree above normal. Wow, I can really feel how warm it is. So pretty much that's a good sign, at least for now. Here's the official data, weekly anomalies for the week centered on July 3rd. This is Nino 1, 1.2, Nino 3, Nino 4, Nino 3.4. Right here is the one we're interested in. 0.3 of a degree above normal, and you see the trend. It's been hovering 1/2 degree or less above normal since the beginning of May. So really no different than what we saw in the previous charts. So what does the atmosphere think is going on? Well, the good news is we have a long-running barometric pressure reading centered in Darwin and Tahiti. I think it's maybe almost 200 years worth of data, at least 150 years worth of data. Okay? And remember, we looked at the high pressure, low pressure bias in the Pacific and over in the maritime continent. Well, that's effectively what this is, but this is hard data from somebody, or at least a machine, reading the barometric pressure every day. When pressure is lower in Tahiti, the index goes negative. And Tahiti, that's what you want. Lower pressure over Tahiti, that would be more towards El Nino. If you have higher pressure over Tahiti relative to Darwin, then the index goes positive, and that's sort of a La Nina indicator. Today's value, 0.468, but that doesn't mean a whole lot because you get a tropical low pushing over Tahiti. That'll drop the pressure. In fact, you can see 1, 2, 3, 4, 5 days. There must have been something going on, and we're down at minus 31. But looking at the trend, it's been generally positive, suggesting the building La Nina pattern. The 30-day average, pretty much neutral, 0.73. That's a plus, but still nothing. I mean, when you're up at 10 or 15, then you're onto something. values, well, you can see we were going from our weak El Nino of minus values to now slowly moving towards positive. But this is more like the active, inactive phase of the MJO. Remember I said the MJO has either like a low pressure or a high pressure. So that can influence this. So this is a good way to look at and get a confirmation on whether you're in the, or have been in the active or inactive phase. 90-day average. Now this goes back 3 months, so it's looking back, at least a month and a half. Minus 1.19. Where were we? Oh, we were down at minus 2 or 3, maybe 4 at one point. So still pretty much all suggesting neutral. In fact, let's go look at a graph. So the Bureau of Meteorology in Australia, that where we get this graph from, they actually updated the graph, the style of it lately. I kind of like this a little bit better. Here is that neutral. They say it's what, 0.7 for the Southern Oscillation Index. So they have a range of +7 to -7, zeros right there. And today we're at pretty much dead neutral. And you see we've been effectively neutral. We tried to go down into, well, this was our El Nino in, let's see. So here was our La Nina back in 2022. Into the early part of 2023, the downward pushes are the active phase of the MJO. The upward pushes the inactive phase. This is the stall of our El Nino back in July and August. And then this was the biggest peak of our El Nino from an SOI perspective was -20. And we weren't even in, this was in almost the summer of last year. And then when we were supposed to be like peaking out, we barely got to -17 for a minute. But for the most part, we were in neutral territory. And at least from a La Nina perspective, that's where we are today. So that's good news. Hopefully we don't go up into the red, but I'm sure we will. And finally, the sea surface temperature forecast for the official El Nino monitoring region, the Nino 3.4 region, from the CFS version 2 model. Well, this is the uncorrected version. The really cool thing, I noticed this. So these are actual temperatures. The model had been, has just been doom and gloom, just predicting, just going down to like at one point -2.2. And even in July, we were supposed to be neutral or negative. But here they just updated it with the actuals. Here's the forecast. Has temperatures still above normal in July, and it then continues to insist that we're going to go into this precipitous drop. I think that is complete nonsense. Yes, we are going to go negative, but I think it's going to be way more gradual than what this model is suggesting. Showing temperatures down to -1.4 degrees. But again, that's the uncorrected version. This is the PDF corrected version. This too has that just precipitous drop-off. Now, we do recall there's strong east anomalies forecast for like the next month. So we'll see whether this materializes, but I think this is still grossly exaggerated. And even this worst case is showing temperatures just 1 degree below normal. From +0.5 to -0.5 is neutral. From 0.5 to 1 is considered weak La Nina, and that's where this has us going. All the other models, I think next week when we do this, the consensus model will have updated, and we'll get to look at all 30 of the different ENSO models, but they've all been saying like 0.8 of a degree, something like that, 0.7. So, if anything, a weak La Nina coming. So the good news is there is surf on the way. It's already hitting Hawaii, the peak of the swell, hitting the South Shore as we speak. Probably will continue into tomorrow morning. That swell, just the very faintest early energy, just starting to hit California. Swell will pretty much continue the whole way through the work week. There might even be dribbles into next weekend. Hooray, there is surf. Looking longer term, though, easterly anomalies, inactive phase of the MJO looks to be setting up. The Jetstream still is supposed to be working its way to the north, so maybe there's some hope here. And typically during a La Nina year, the focus of southern hemi storm production is typically more in the southeast Pacific. Coming out of El Nino, typically the focus is under New Zealand. So we have been in that New Zealand pattern hard for the past couple of months. Wouldn't be surprising to see things start shifting off to the southeast as La Nina becomes more entrenched. but that's a bit of a guess. We'll see how that all plays out. And then beyond, well, going into next winter, some sort of La Nina expected. The question is how strong. It might be a minimal, and if it's a minimal, that would actually be a good thing. That would at least give us, and lingering energy from last year's El Nino still would be in the jet stream, offering an opportunity for at least rainfall into California. Hopefully, probably not normal rainfall, but probably not some big drought thing, maybe 85% of normal rainfall, but that's a wild guess seeing how it's July and we're trying to predict rainfall for next January and February. But we're hoping we don't get into too deep of a La Nina, and for right now, all the data suggests that's exactly where we're going. All right, if you enjoyed the video, give us a thumbs up. If you have a question, write it up down below. If you haven't subscribed, click the subscribe button, the Stormsurf logo down the lower right-hand corner of your screen. And if you'd like to make a contribution to the cause, you may hit the special thanks button, the heart with the $sign in it down below. With that, we are done for this week. We will do it again next week, same time, same channel. Thanks for watching.